Right, polynomials 1.4. We're now looking at relating the functions to the equations and the graphs. We're going to be looking at that as well. So if you haven't already done so, please do this now. Match the graph and the equation together. And try to do it without punching it into your calculator. Try to look at the equation and see what graph we come up with. And then look at what characteristics led you to that graph. Okay, so looking at what we've got here. First one, we've got an x squared with a positive in front of the x. Second one, we've got the x squared with a negative in front of the x squared. Then if we look at after those two are a plus 4. That plus 4 is saying that we are moving it 4 units up. Okay, so then we look, say, okay, the positive one in front means it's opening up to the positives. So this one is either going to be graph 3 or 4. The negative one in front is telling us that it's opening down. It's either going to be 1 or 2. So let's look at the first one. It's opening up, and it's 4 units up from the origin. Oh, that's this one. The second one is opening down and 4 units up from the origin. That's this one. Then the next one, if we just use that same key information, the first part is negative, so it's opening down, and it's 7 up from the origin. Okay, well, oh, that one's 7 up. It's also, if you notice, 1 to the right. Yep, that looks good. So this is number 3. And obviously this one has to be number 4. And we'll talk more about other characteristics that you could see. Taking that now from the quadratics, which you learned before, and taking them into these new graphs. Whoa. Try to match these ones yourself if you haven't done so already. All right. We're going to use this first the same thing that we used with the other ones. If it is a negative in front, it's going down. But we can't just say opening down, because if we look at some of these, they start on one side, they go the other way, a little bit more happening. So, if you punched into your calculator to see, you would come up with the answer as well. And I will just give you the answers from your calculator, and then I'll explain the characteristics that we're going to be looking at. So the first one, we've got a negative in front. These are the things I'm looking at. I'm looking at this, and I'm looking at that. For that one, it's going to be this and that. So this one is going to be number 1. As we're going along, you might see how I'm using this. For this one, I'm using that, and I'm using that. I'm going to be using this, and I'm using that to make this number 2. Number 3, I'm using that, and I'm using that. And that is going to be number 3. That and that. And then obviously the last one, but I'm going to go through again. I'm using that number there, and I'm using that number there. That number there, and that number there to give me number 4. And that's the point of this lesson, is to see what the heck I'm doing there with that and that. Linear, quadratic, cubic, quartic, quintic. What does that mean? degrees. That's a degree of 1, x to the 1, quadratic, x to the 2, cubic, x to the 3, quartic, x to the 4, quintic, x to the 5. You need to know those names that go along with them. The degree of the polynomial function is the highest power of the variable. So when you look at, you go through and say, oh, the highest exponent, the highest power there is a 5. Therefore, it is x to the 5. It is a quintic polynomial. Everything after quintic, we just say 6th degree polynomial, 7th degree polynomial. Polynomial function of the degree of that, whoa, this looks like craziness. All this is saying is that the a values are different. They don't have to be the same. And the n value, the exponent, we put them in descending order. Go down by 1, go down by 2. So we just keep going down. The example that they gave up here was not in the correct order. We got to put it in descending order. The graph of a polynomial function is smooth and continuous. Nice curves. Which means it has no sharp corners and can be drawn without lifting the pencil from the paper. All right, so first question that we're going to be going through. And that's on your bit.ly link. And we're doing capital T, small s, 4, small c, capital G, capital W. Go to that, sign in with your Google account, and answer this question. What is the leading coefficient of this polynomial? 3, -5, 5, -2. Okay, so polynomial function now can be described by its degree. An even degree function or an odd degree function. Even degree is going to mean you've got x to the 2, 4, 6, 8 as the highest exponent. An odd degree function is going to have a 1, a 3, 5, 7, 9, an odd exponent as the highest exponent. So if we look at this, a positive leading coefficient on a degree of 1. Degree of 1, the name is linear. It is an odd degree because it is an exponent of 1. If we have a positive leading coefficient means a positive number in front of the x. That's a positive slope. If it's a positive slope, the slope is going up. So we're going to look at positive slope. Where is it finishing? It's finishing going up. So I'm going to say it this way. If you live a good, positive life, you will finish going up. Now, negative leading coefficient. If you lead a negative life, negative slope, it will finish going down. Let's go to the next part here. Let's take it to a degree of 2. That's called the quadratic. Even or odd, that's an even. And again, we look at that positive leading coefficient. And if it's a positive leading coefficient, that means that it finishes going up. We're only worrying about where the end behavior, where it finishes. A moment. If it's a negative leading coefficient, it finishes going down. When we had an odd degree to begin with, here, for the first one, an odd degree is going to start in the opposite direction that it finishes. So in the degree of 1, it finished going up. We always look at that first. Always look at finish, where it finishes first. It finished going up because It was a positive leading coefficient. The odd degree now means it's going to be starting from the opposite direction. Odd degree, it finished down, so it started opposite. Odd, opposite. Or an odd person is different. Even. When we have an even degree now, it's going to start in the same direction as it finished. In the first one, leading coefficient was positive, it finished up. We start up. In the second example here, it was a negative leading coefficient. It's still an even. It ended down, it starts down. Starts in the same. So an even is equal, same. Same direction. Let's look at the degree of 3. Does this hold true? Yes, it does. So you've got your positive leading coefficient. That just tells you where it ends. It ends on the way up. But if we look at our exponent, it is odd. That means it is the opposite direction. Okay, so the same thing goes with the next one. It is a negative leading coefficient. It finishes down. It is an odd degree, so it starts in the opposite. Let's go to quartic. Okay, quartic is a degree of 4, even degree. Leading coefficient is positive, finishes up. Degree is even, starts same. Leading coefficient is negative, ends down. Even degree, starts same, so down. Always do the leading coefficient first. And the last one we're going to look at, quintic. Same thing. Positive leading coefficient, ends up. Odd degree, starts opposite. Leading coefficient negative, ends down to the negatives. Exponent is odd, opposite. All right, what kind of polynomial function does this graph describe? Is it even or is it odd? And just for yourself, be thinking as well, and I'll have that as a question on there as well. Is it even or is it odd? And is it positive or is it negative? So there'll be two parts of this question, even or odd, and is it positive or negative? Leading coefficient. Try that. That's on the bit.ly loop. So in a polynomial function, a point where the graph changes from increasing to decreasing is called a local maximum. Right there. Those are two local maximums. Where it goes from decreasing to increasing, so the first one was saying increasing to decreasing. Increasing to decreasing. That's a maximum. If it's going from decreasing to increasing, then that is your min. A local minimum. And then we actually call the one that's the absolute highest point, this would be an absolute maximum as well as a local maximum. So if we start looking at the graphs, a graph, its degree, if it's x squared, it can have at most 2 zeros or x-intercepts. A cubic can have at most 3. So what we're talking about here is it can have at most n intercepts, if it's a degree of n, and at most one less local max or min points. So cubic, most it can have is 3 x-intercepts and 2 max or min points. To sketch the graph of polynomial functions, you can use a table of values and your knowledge of the end behavior. We'll also give you a bit of information to be able to sketch it quicker without having to do a full table of values. So we're going to sketch the graph of each polynomial function here. All right. Well, table of values is a way we'll start with it, just like they show. So we're going to take some negatives, some positives, and 0, what we always want to use. So we're going to use x and a y chart. I'm going to use -2, -1, 0, 1, 2, 3. Actually, maybe I'll even go to 4. There we go. I'll go right to 4. We look at it and we say, hey, it has a positive leading coefficient. So I know that it has to end going this way. And it has a degree of 3. That means it has to have started in the opposite direction. And then it's got to do something in between there. So let's start looking at from there. If we plug in -2 in there, -2 cubed minus 3 times -2 squared, we should come up with -20. At -1, plugging it in, you should come up with -4. At 0, plugging it in, it's going to be 0. 1 plugging in comes out -2, -4, 0, and 16. So we just start graphing those. Okay, 1, 2, 1, 2, 3, 4. So at -2, it's like way down at -20. At -1, it's like at -4 or something like this. We're just sketching, so we're just getting as close as possible. Just the idea of the graph. At 1, 0, and 0, 1 and -2. Like that. And then 2 and -4. And 3 and 0. And 4 and like 16. Let's connect those dots. Starting here, going up to there, going back down to there, going up. Oh, look at that. It followed what we said, and we've got a nice curve. Let's look at the second one. For the second one, if you want to get yourself ahead, I'm going to use for my table of values -4, -3, -2, -1, 0. You can use anything you want, but those are good ones to use. You'll see why. I'll also, just because I want to put a positive one as well, throw a 1 in there. All right, so graphing that up, we've got, I've got to fill in the numbers first. Plugging that in, the -4 in for the x, you get -13, 3, -1, -1, 3, and -13. Okay, so we start. And we know that it is a negative leading coefficient, so it's going to have to be ending down. And it's an even, so it means it started down. Let's make sure that it works the way we think it's going to work. So at -4, it's like -13, something down there. I'm not worried too much. I'm just sketching. A sketch doesn't have to be perfect. -3 and 3. So 4, -13, -3 and 3. Up here somewhere. -2 and -1. Oh, look at that, it came back down. -1 and -1, and 0 and 3, and 1 and -13. So it's got to look something, and again it's a sketch, so it does not have to be perfect, but it's going to be something like that. And yes, that followed what we wanted. It ended going down because of the negative in front, and it was started and ended at the same place because it was an even. Well, example number 2, we're going to take it a little bit further. We're not going to use that table of values. We're going to sketch it by using what we just learned in this chapter. If we factor, thinking back to when we did quadratics, if you factor a quadratic, you can find the zeros, the x-intercepts, from those factors. Same thing here. As soon as you factor the polynomial, you can find the zeros. So we can use the zeros, the x-intercepts there, and the y-intercepts, and that end behavior of the, does it end going up or down? Put that together and we can sketch. So let's start by factoring. So the first thing, this is a nice easy one to factor. We can factor out GCF. First step factoring GCF. So f at x equals x bracket x squared plus x minus 6. Then we're using our sum product factoring, and it factors into x plus 3 and x minus 2. The factors are x, x plus 3, x minus 2. Those are the factors. So the zeros are when we make this equal to 0. That's your x-intercepts. X-intercepts are when y equals 0. F of x, or f at x, is the same as the y. It's a fancy y. So then we know at this point that either x equals 0, x plus 3 equals 0, or x minus 2 equals 0. X equals 0, there's 1 0. X plus 3 equals 0, so x equals -3. There's a second 0. X minus 2 equals 0, so x equals +2. Those are the 3 x-intercepts. Hey, let's put that on right now. It has to pass through 0, -3, and +2. Now, we don't know which way it's going to go. It's going up through it, down through it. Let's look at our end behavior. Positive leading coefficient. That means it is going to end going up. Odd degree. That means it's going to start opposite. We know then it's going to come up through this one, and it's going to have to curve going down and then back up. The other thing that you should be looking at, you've got your x-intercepts. Oops, write it in green. Your x-intercepts that you found. You should also look at finding your y-intercepts. In this one, we already found it. It was 0 and 0. But in order to find a y-intercept, that's when x equals 0. So go back and do f of 0. What is the function at 0 there? So 0 cubed plus 0 squared minus 6 times 0. Oh, that does equal 0. So when x equals 0, your y equals 0. That means your y-intercept is at 0. Which, yep, that's what we had here. Sometimes you're going to need to do that as another step. Okay, so answer your thinking further for yourself now. So just like I said, when you factor it, the factors are you're able to find the zeros from the factor by equating them to 0. All right, another quick question. Answering that for yourself. What are the x-intercepts of that one? A, B, C, or D? Now, that's all fine and dandy for finding the zeros from the factors if they're all different. But now what happens if we have factors that are repeated? For instance, if we factor this one, we get x minus 1 squared, or x minus 1 times x minus 1. 2 of the roots at x equals 1. We've got 2 of them. We know here that it had an exponent of 2. That means it's going to have a multiplicity of 2, which means there's 2 zeros at the same spot. In this case, 1. If we factored this one here, and we came up with x minus 1 cubed, that equation has only one root of, again, 1. But because it is cubed, there's going to be 3 of those same factors. It's going to have a multiplicity of 3, or 3 x-intercepts at the, or 3 zeros at the same x-intercept. So how would we graph those? It would look like this. When we have a multiplicity of 2, the graph bounces off the x-axis. When we have a multiplicity of 3, it kind of turns along it. It doesn't go nicely straight through it. It turns through it a little bit. This here we refer to as a point of inflection. Let's look at, actually before I do example number 3, I'm going to let, instead of the lady talk to you, today you've got a new person talking. We've got
Part A.
This guy.
Sketch the graph of the polynomial function.
And again, they're going through the one in the textbook. They're going to walk you through the information. And then I'll do question number 3.
f at x equals x minus 1 squared times x plus 3 squared. The first thing I want to do is find the zeros of the function. These will be the x-intercepts of its graph. So I let f at x equal 0. The equation will equal 0 when x minus 1 equals 0, or when x plus 3 equals 0. So x equals 1, or x equals negative 3. So the zeros of the function are 1 and negative 3. I can plot points on the x-axis at 1 and negative 3. The 0, 1 has multiplicity 2. This means that the graph just touches the x-axis at x equals 1. So the graph at that point will either look like this or like this. The 0, negative 3 also has multiplicity 2. This means that the graph just touches the x-axis at x equals negative 3. So the graph at that point will either look like this or like this. The equation has degree 4, so it's an even degree polynomial function. The leading coefficient is positive, so the graph opens up. Since the graph opens up, I know that it will open up at x equals 1 and x equals negative 3. The y-intercept is the value of y when x is 0. So the y-intercept equals negative 1 squared times 3 squared, which is 1 times 9, or 9. I can mark a point at 9 on the y-axis. Now I can draw a smooth curve to connect the parts of the graph. Part B. Sketch the graph of the polynomial function. g at x equals negative x plus 2 cubed times x minus 1 squared. I'm going to start by finding the zeros. When g at x equals 0, x plus 2 equals 0, or x minus 1 equals 0. So, x equals negative 2, or x equals 1. The zeros of the function are negative 2 and 1, so I can plot points on the x-axis at negative 2 and 1. The 0, negative 2 has multiplicity 3. This means that the graph crosses the x-axis at x equals negative 2. So the graph at that point will either look like this or like this. The 0, 1 has multiplicity 2. This means that the graph just touches the x-axis at x equals 1. So the graph at that point will either look like this or like this. The equation has degree 5, so it's an odd degree polynomial function. The leading coefficient is negative, so as x approaches negative infinity, the graph rises, and as x approaches infinity, the graph falls. This means that the graph rises to the left like this, and falls to the right like this. The y-intercept is the value of y when x is 0. So the y-intercept equals negative 2 cubed times negative 1 squared, which is negative 8 times 1, or negative 8. I can mark a point at negative 8 on the y-axis. Now I can draw a smooth curve to connect the parts of the graph.
Another riveting video. All right, let's look at our question that we're going to do. Sketch the graph of the polynomial. So, one thing I do want to remind you right now is if there's a multiplicity of 2, 4, 6, any even multiplicity, then it's going to either bounce off on the top or bounce off on the bottom. If there's an odd, change colors, there's an odd multiplicity, that's, I'm going to say 3, 5, or 7, it's going to do a slight turn in one of those two directions. Well, why did I leave 1 out? Well, if it is a multiplicity of 1, then it's just going to go straight on through. Either that way or that way. So it kind of looks similar to the odd ones, but it's just going to be a straight line through instead of a curved line through. All right, well, let's quickly sketch this one up. We've got a 0 at negative 1 and a 0 at 2. Let's put those on. Negative 1 and 2. We've got a multiplicity of 4. That means at the negative 1, it's going to be even, so it's going to be one of these ones. And now, we need to use the information that we had from before. The leading coefficient in front, if we multiply and expand this, it would be positive. So we know that it has to end going up. We also know that it has a degree of 4 plus 1. So it's a degree of 5 for the whole polynomial. Because of that, we know that it ends going up, but it had to have started in the opposite. So we're going to start at the beginning here, coming up. We hit the 0. We need to know what to do. Well, at that 0, it's going to bounce off and reflect back down. Good. And then somewhere it's going to turn to come back up. I don't care where, really, right now. And then it's going to hit the 2. And then I got to figure out what to do with that. Oh, it's a multiplicity of 1. So it's going to be just going straight on through and connecting with the end there. And I've now did a quick little sketch. Let's look at the next one. We've got zeros at -1 and at 3. I'll put them on. -1 and at +3. From there, we're going to use the same information. It ends, if we multiply it all up, we've got a negative in front. So that means it's going to be ending down. Let's look at our degree. Our degree is 3 on this one and a 1 on this one, so it's a degree of 4. So with that, it's got to start and end in the same direction. So it's going to start coming up towards 1. Now, it's got to do something. It's got a multiplicity of 3, so it's going to be doing a little, oops, that looked a little bit like garbage. There we go. Oh, let me redo that. Yikes-a-ronies. Coming up, and there we go. Then it's got to turn back around and start coming towards the 3. Again, it's got to do something at the 3, and because it's a multiplicity of 1, it's just going to go straight on through. And yeah, it connected up to where we were at. We've got a quick sketch of what it was. All right, go through and answer up your 2 discuss the ideas questions right now for yourself. And then you can attempt some of the assignments if you'd like as well.